All right. So, continuing on through chapter 1 here. So, if we do the kickoff first here, what shape does the following net make? Well, when we get to looking at, we have all squares, and we have 1, 2, 3, 4, 5, 6 of them, and we know a cube is made up of 6 squares, and so a cube, it would be. Not a greatly drawn cube, but a cube it is. So, if we looked at this map of Platte County, so what geometric term would describe each object? So, if we look at a town there, so we have the town of Humphrey here, what is being used to describe that town? Well, we have a little dot here. If we look at a highway, say Highway 81 cutting through, what do we use there? Well, that's using a line. Then lastly, what about the whole county? Well, we have lines going around the outside, but now we've become, even from a single dimension of a line, of a dot or a line, now we're a 2-dimension of a space here. Well, that would be described as a plane. So points, lines, and planes are the 3 basic terms that will make up all of geometry. So a point is going to be a location, and a set of them make any geometric figure. So really, a point is our main building block of all geometry. Now, when we write this, we're going to represent it with the capital letter, and it technically has no size. It's so infinitely small, there's absolutely no size to it. Now, space is going to be the set of all points. So even in the room you're in right now, there is an infinite amount of points that could take up and fill that room. Now, a line is going to be a series of points that's going to extend in 2 directions, opposite directions more importantly, forever. That's why we put the little arrows on the end. It's going to keep going on and on and on and on and on. And it's in complete opposite directions forever. Now, when we represent a line, we use 2 points that are on that line. So say, for example, AB with the little line above it, or we'll use a single lowercase letter to do that. Say, for example, T. So if you look at that figure there, we have 2 points on this line AB, so we could write it like that, or we could call it line T. Either way works. Generally, though, you're going to see it, the AB with the 2 points, sort of a thing. Collinear points are going to be all points that lie on that same line. So there could be, say, a point here that's C. There could be a point, say, here that's D. There could be a point here that's E, and so on and so on. All of these points are on the same line, so therefore they are all collinear. So collinear just means same line. So, looking at this figure here, are points E, F, and C collinear? Well, E, F, C, yeah, they're all on that same line. So, yes. What line are they on? Well, we could either say line M, because they're all on line M here. We could say they're on line EC. Maybe we're FC. Any of those would work to describe what line they are on. Are points E, F, and D collinear? Well, now we have E, F, D. Well, no, these 2 are going this way, and then this one's over here. So D and F would be 1, D and E would be 1, E and F would be 1, but all 3 are not on the same line. They have to go in opposite directions, that line. Our lines do not curve or bend. They're not a line then. So in this case, no. So what is another way to name line M? Well, I did that up here, I guess. EC, FC, we could use EF as another way. Now you might be going, well, if I say EF and then do FE, is that two different ways you can name it? Well, technically two different ways you can name it, but you're talking about the same line. So it doesn't matter what order the letters are in. That doesn't make it two different lines. It's still the same line, even though they're just, the letters are switched around. So why are the arrowheads used when drawing the lines? Well, to show it goes on forever. So it's going to keep going opposite directions forever. Now, we talked about a plane before. So a plane by definition here is, I'm going to adjust my camera just a little bit. So a plane is going to be a flat surface with no thickness, and it's going to have infinite amount of points and lines extending in all directions forever. So it's represented by a single capital letter or by at least 3 non-collinear points. So any points or planes on a plane are collinear. So they should be plane, not plane. So, or coplanar. Coplanar, not collinear. So collinear means same line. Coplanar means same plane. So we use 3 points to represent a plane. Just like if you think of like a camera tripod, it needs at least 3 points in order for it to stand. If it's only 2 points, it could tip over back and forth. 3 points makes it stay. So we need that plane, that area. So you see it like this. Either we'll say plane P, which is 1 point that's on that plane, or we'll say 3 non-collinear points because that'll represent that space. And we get plane ABC. Now, with geometry, there are certain automatic truths that we follow in geometry. So these are called postulates or axioms. Now, we will refer to them as postulates. Other spots in geometry calls them axioms. They're meaning the same thing. They're automatic truths, truths that are right no matter what. And there's no real way to prove them. It's just automatically, this is how it is. So, postulate 1-1. Through any 2 points, there's exactly one line. So what that's saying is, hey, if we have A and B here, there's only one line that can go through those. Well, one line, it's forever in opposite directions. So there's only one way to go through that. Any other line that would come through here wouldn't be a line because it'd have to curve or bend, that it wouldn't be a line. Postulate 1-2. If 2 lines intersect, then they intersect at exactly 1 point. So as we come through here, line M and line N, well, they're exactly at point C, they're intersecting. L and M at point E is the exact point they're intersecting. D for N and L. So remember, a point has no thickness. And so if a line is made up of an infinite amount of points, that line has no thickness as well. So it can only go through one single point. It's not wide enough, there's not thickness there so that it goes through more than one. Postulate 1-3. If 2 planes intersect, and they intersect at exactly one line. So as you look here, this plane here is going through, this plane here is going through. Well, they're only going to intersect at this one spot. Well, because we have 2D space, they're going out forever in all directions, the one way, and then it's tipped and it's going through forever in all directions the other way. Well, they're only going to cross at this one line because, again, there's no thickness because it's made up an infinite amount of points. Points still have no thickness. So, again, it's only going to be one single point all the way across here, making the line that's going to cross. And postulate 1-4, through any 3 non-collinear points, there's exactly one plane. So that's where we talked about before we say that tripod. There's only one plane that would exist where those 3 points exist. Because again, a point has no thickness, plane has no thickness. So if there was any more thickness that they could go through more, then it'd work. But otherwise, there's only one plane that would work. Otherwise, it's not going to be a plane. There's going to be, again, just like a line wouldn't work if there's a bend. Planes can't have a bend in them either. So, name another point that has, or that is in the same plane as F, G, and H. So if we're looking at this, we have F, G, H. The only other point that's in that one would be point E. Name another point that is coplanar with A, B, and C. So coplanar means same plane. If we have A, B, C, the only other point that's in that same plane would be D. So that's it for this lesson. Let me know if you have any questions. You can email me, pan me, send me a message on Google Classroom. Otherwise, until next time, we'll talk to you later.